Welcome to Beta Talk. This is a podcast I usually do on a audio podcast, and we're starting to do some Zoom stuff during lockdown. I'm going to introduce you to my three guests today. Jan has been on before with me. Jan is the Principal Director of the European Programs at the Regulatory Assistance Project, which is known as RAP. He's had several board appointments, or he's got several board appointments. He sits on the Executive Committee of the International Energy Agency's Demand-Side Management Programme, the Board of the European Council for the Energy Efficient Economy, and the Board of Directors of the Efficiency Evaluation Organisation. He is a member of the Steering Committee of the Coalition for Energy Savings and the Build Upon 2 Advisory Board. He's also an honorary research associate at Oxford University's world-renowned Environmental Change Institute, and he's been interviewed by various people such as Bloomberg, the BBC, the Times, the Guardian, etc. I've also got with me a good friend of mine, and I'm just changing my screens about here, Peter. Peter and I both live in Suffolk. Peter worked in the first computer shop in the UK, I believe, and studied under the professor at Manchester University, who I believe also was instrumental in the development of the first laptop. He also helped or coded the lighting and sound sequence for the 1988 Olympics. So he's a very good coder, good friend of mine. And we're also joined by Karlos. And Karlos is a very, very unique gentleman that we all happen to know. He runs the company, or is the founder of a company called Octopus Energy. And he's going to tell us a little bit more about that. And today's topic is electricity cheaper than gas? So we're going to be talking about Agile Tariffs. Now, Peter, you've got Agile Tariff. Tell us a little bit about what it actually is.
Okay, well, there are times of day when electricity is a lot more expensive to generate and to distribute than it is at other times. As a user, we can either have a fixed rate tariff, 15, 16 pence a unit throughout the day and night. Then for a long time, we had the tariffs which were cheaper at night. Agile Tariff actually gives you a tariff which varies in half-an-hour segments throughout the day and is set 24 hours in advance, thereabouts, and will typically, well, we're not living in typical times because we're in lockdown and energy demand is lower, prices are lower. But for most of the day, I'm currently paying 4, 5, 6, 7, 8 pence a unit. Between 4 o'clock and 7 o'clock in the evening, when everyone's cooking tea and the demand for the grid is at highest and demand for electricity is highest, the price can be as high as 20 odd pence, 20, 25 pence. So the idea is that I'm a very heavy electricity user. As well as all the normal things around the house, I've got a heat pump. So all the heating is electric. I've got an electric car, which needs to be recharged. We've also got some PV. And I've got an electric water tank from a company, Mixergy Limited, which is a stratified hot water tank that I could choose to fill up at any time through a 36-hour period. And I will have lovely hot water for the rest of the time. So I've got a lot of agility as to when I choose to use that electricity, but I don't want to be looking at the tariffs every single day, choosing when to turn things on and off, which is where Karlos and Octopus Energy come on, because I have their device which basically looks at tomorrow's electricity prices and looks at the weather forecast and strategizes when to run my heating and when to run my hot water. I've also actually got a 3 kilowatt hour battery, domestic battery, that can, again, has some agility as to when it charges and discharges.
So, Karlos, the thing you've developed then sort of automates when the cheapest tariffs are going to be around. Is that right?
So it takes the information from Octopus Energy. So the way that the Octopus Energy tariff works is that every day at 4:30 p.m. you get they publish new set of prices for the next 24 hours. So a day in advance, you know where the prices will be in each half-hour period for the next 24 hours. And I can share actually just an example of my prices for the next day. So I am an Agile customer.
Yep.
And I'm just going to share my screen.
Yep.
So if we look over here, and I just wanted to actually compare it with the fixed tariff. So at the moment in my area, the price of electricity, if you were on a fixed normal tariff, would be 14.6 pence per kilowatt hour. Now, my prices, so this is for yesterday and today. You can see how the prices are different in each half-hour period. So for example, today, 5th of May, between 12 and 12:30 in the morning, I was paying 4.64 pence per kilowatt hour. That changed to 3.57 pence per kilowatt hour. And these prices are different throughout the whole day. And they are, as Peter mentioned, dependent on the current production of power and the demand of power. There is a peak period, so between 4 and 7 p.m. We do have prices that are much higher than normally. But if we can shift our consumption away from these periods, we can get quite a good average price of electricity that we pay for our heat pump.
So we're talking about some quite low prices there, aren't we, Karlos?
Yes. So I can also share. So thanks to Peter, he let me share his data from his system. So this is just for one of the days, and this is the information that we collect, and it just shows how the system is operating. So as I've mentioned, say in advance, 4:30 p.m. hits, we get a new set of electricity prices. Our system reads those. It takes a look at the weather forecasts for the next day. It takes a look at how your building is behaving. So in terms of how long it takes for your house to heat up and cool down, and it figures out the best optimal schedule for heating your house and heating your hot water. So this was on the 1st of May, and just quickly run through. So internal temperature is the top graph. Heat pump temperature. So this is flow and return temperatures. Wow. And this is, I think, something that you've mentioned would be quite interesting for the installers to keep track of to make sure that the heat pumps are operating correctly. These are the controls. So when the orange line goes up, that's when the heating is on. When the gray line goes up, that's when the hot water is on. And this screen actually shows the electricity consumption at different points of the day and the electricity prices. So you can see how throughout the day, we started off the day with 3.53 pence per kilowatt hour. That went up to 4 pence. In the morning, it went up to 6 pence. And our system knew that that was going to happen. So it preheated before the morning peak to make sure that Peter is nice and warm in the morning when he gets up. And also it preheated before the evening peak to make sure that his house is comfortable when in the evening.
And you've got the weather one on the bottom as well, yeah.
Yes, so this is also the weather temperature as monitored at his property. For this particular day, for example, the average price of electricity that he actually paid was 4.08 pence per kilowatt hour, which compared to the I'm not really sure what the fixed rate at his area currently is, but this would be slightly lower, probably.
Could I come in there and just say that 4 pence is also about the price that you would pay for gas. Yeah, that's about the price per kilowatt hour of gas. But a heat pump is running within a COP an efficiency gain of, well, at least 2.5 when it's in cold weather to 3.5, which actually means you can divide that figure of 4 pence by about 3 on average throughout the year, which means the cost of my heat is just over a penny per kilowatt hour at that rate. And now, before we went into lockdown, when we were in midwinter, when it was colder, those prices in the day might rise above 12 pence or something. But still, there would be very cheap periods during the night when one can do a lot of preheating downstairs, not the bedrooms, but the downstairs rooms, which then means there's very much less work for the heat pump to do during the day when the prices are high. And you can completely avoid the 4 to 7 p.m. peak when the prices go very high. Indeed, with a battery and with a PV system, quite often I'm exporting at those periods. So I will be delivering, I'll be buying electricity in the middle of the night, filling my battery with PV during the early afternoon. And then at 4 p.m., I just put the thing on forced discharge and can be exporting, because as well as the price variable price you get paid, you get charged for buying electricity, you can get paid a variable price for the electricity that you export, and that price is highest between 4 p.m. and 11 p.m. And just to sort of just say where I'm going to, the battery system I want to put in will basically have the ability to import or export up to 6 kilowatts. So it can take 6 kilowatts from the roof and put it in the battery, or it can take 6 kilowatts from the battery and put it out into the house or onto the grid. And next year also, there will be a two-way charger available for the Nissan Leaf, which will be able to operate up to 7.5 kilowatts. At which point, if that's a bit of a luxury item at the moment. It's over £5,000, so it doesn't justify itself economically. But as the price of that unit comes down, and it will, I can envisage a time within a couple of years when my house, between 4 p.m. and 7 p.m, will be able to export 15 kilowatts.
Right.
Right. For the car, it will be able to export 7.5 kilowatts for each of the half-hour periods between 4 p.m. and 7 p.m. For the domestic battery, it just depends what the charge in the battery is. If it's a 6 kilowatt-hour battery, it'll be able to do it for 1 hour. But what we actually will be able to see for Agile customers with this sort of equipment is that their demand will be the reverse of the price, which means it's the reverse of the demand of the rest of the system. So we will be using large amounts of power, recharging cars, heating, using hot water when everyone else isn't using it, when the wind's blowing at night and there's no one else using it. And then at the peak times of day, when everyone else is using it, we will actually potentially become major exporters. My house will then be able to cook the tea of about 6 or 7 houses on the street.
It becomes a little mini power station in its own right.
It does.
Now, Jan, actually, I was going to ask you, Peter. I did a podcast yesterday, and the question was, do we need to upgrade from single phase to 3-phase? Now, you just said you've got battery, you've got your car. Have you got single phase, or have you got 3-phase?
I've got a 100 amp fuse single phase, which means I can import or export up to 20 kilowatts. One of the other things that the sort of hubs that Homely Energy do is they can look at peak loads, and they can actually also look at make sure that they don't overwhelm. They don't run the heat pump if, in doing so, they blow the fuse. They don't export more than would be sensible to given the fuse rating of the house. And also, I have no electric showers and things. I think some of the stuff yesterday was assuming worst case. A lot of the people who are putting in heat pumps to start with tend to be larger houses, tend to be more substantial houses, and so we're seeing very large houses with a lot of electric showers, a lot of electric equipment. Most houses really just don't come into that category. I mean, and the amount of power we need is, I think, entirely suitable for a single phase. That's not to say that they don't have a point, that when everyone starts basically using these higher powers, responding to Agile tariffs, we're going to see very sharp jolts in how much electricity is taken. And if, for example, on our street, all the people who happen to put equipment like mine were on 1 phase, and all the people who were using power on the other phase, we might find that 1 phase was overcome with incoming power, with exported power during the peak, and other phases were using it. So I think there will be a challenge for the grid operators down the line if these Agile tariffs become very popular, because they are going to start destabilizing the grid in a new way, and then one will have to respond to that. But I sort of feel like I've spoken rather a lot. I wonder if Jan has got anything to.
There's a balance, Jan. So one of the like we've just said there, one of the questions we asked yesterday is do we need to upgrade to a 3-phase supply? And obviously we get this question all the time, and you must hear it all the time: is can our grid actually cope? And so, what is your opinion on that?
So this is a question indeed that comes up every single time that one discusses electrification of heat. And yes, of course, once you get to really high levels of penetration, there will need to be upgrades. But where those upgrades need to happen and to what extent, that really differs across the country. So you may imagine, a very densely populated street in London that would have very different implications for heat electrification than an off-grid property where there's a lot of underutilization of the grid. The geographic disparities of where those upgrades will need to happen will differ. And certainly in the existing grid, there is still some space, and we looked at, this was a European study, we looked at different countries and to what extent the grid is underutilized. And we found that in many places, there's still a lot of space in actually utilizing the grid more and adding more capacity usage to the grid without needing to upgrade immediately. But yes, there will be a cost of doing that. But I think that's why we talk about Agile today. One way of minimizing that investment requirement is to optimize the demand, which means following the provision of electricity through renewables more, avoiding the need for peak demand and capacity to be expanded during peak hours. So I think that's why the technology that Homely offers, for example, is quite interesting, because you can actually manage heat loads in a way not only to optimize prices, but you can also use that technology to minimize the impact on the grid if you just gave it the right signals. And I'm sure Karlos will have some thoughts on how that could be done. But I have seen, for example, a pilot study by Dong Energy, which is now Ørsted in Denmark, where they have actually managed heating loads by also looking at what it means for managing the grid by having a sort of network tariff that was time of use based. So there are certainly opportunities there. But yes, you're right, Nathan, there will be some need. But it always depends on, compared to what. I mean, the cost of doing all the other things will also be significant, and we have to make that comparison to really answer the question whether it makes sense or not.
I just want to clarify something for my listeners. So a listener could get Agile Tariff at the moment. The one we know is Octopus, isn't it? What is the difference if they just get that, and then if they got that plus Karlos's system? What's the difference? Karlos, it's probably best for you.
I can answer that, because we only switched recently to the Agile Tariff, and we were on gas before, so I paid close attention to the cost because I was a new customer and I wanted to see the benefits. So overall, we have more than halved what we pay per unit of electricity, I would say, by simply using our heat pump in a smart way and avoiding the peak. And per unit of heat that we provide with the system, it's less than 50% of the cost that we had previously, simply by using the Agile Tariff and by having a smart control of the heat pump. So there's a cost saving there if you do that. And I think there's lots of opportunity for other customers to do that. However, if you're on a flat rate, you actually have zero benefit of using the Homely system, I would have thought, because you're essentially paying the same whenever you use electricity, and there's no difference to the unit cost. So you really want to be on a more flexible tariff if you want to benefit from that kind of technology.
What's your thoughts on that, Karlos?
Yes, so it's great to see, because both Jan and Peter are both customers of ours, and they're both using the kit, so it's great to hear their opinions. Yes, if people are on a fixed tariff, there isn't really much use for our kit, in terms of that their heat pumps are probably already managed to make sure that the temperatures are correct at the right times. The whole purpose of our kit is to make sure that we switch on that heat pump during the cheapest periods of the day. So we try to pick out those cheapest pockets of electricity that are there. So if I can just share my screen quickly once again, I'd like to just show how different they are. So can you see my screen?
Yep.
So over here, for example, so just looking at the hot water production, we can see how throughout the day, there were some very low cost periods. So for example, this 3.31 pence, and over here where the price dropped to 2.69 pence. And the heat pump was actually operating during these times to heat up the Mixergy hot water tank.
So
the other times as well.
Grey is hot water, I'm assuming, and the orange is heating.
Grey is hot water and the orange is heating, yes.
Yep.
So even throughout the day, so we know that the electricity price is cheaper throughout the day than the fixed tariff when you're on Agile for majority of the days. But even that morning peak, which is 6 pence, it doesn't seem like a lot, but it's still a lot more than, for example, throughout the night when you have 3 pence per kilowatt hour, or here 2 0.69 pence per kilowatt hour. So the whole purpose of the kit is to make sure that we're picking out those cheapest pockets of electricity to make sure that people are comfortable in their homes at the right times.
So what I want to get to grips with is, if I was to have Agile, would it make extra sense to have your system as well? Because it automates it.
Yes. So instead of you running to your heat pump every half an hour to try and switch it off, we try to automate it. So you provide us with your preferences. So you tell us when you want your house to be warm, and you provide us a little bit of information on. So I want my house to be warm between 6 and 10 o'clock in the evening. I want it to be 20 degrees between 6 and 10 o'clock in the evening. I know that the prices of electricity are expensive between 4 and 7. What the heat pump can do is it can slightly overheat the house before 7 p.m., before 4 p.m. So heat it to 21 degrees, turn off the heat pump just before 4, let the temperature drop to 20 degrees, which was your set point initially, and you are then comfortable at the cheaper cost.
So just tell us a little bit. So the way the electricity is bought and sold, does this go on the same in Europe? Is it exactly the same system, how the electricity is bought and sold, or it's got these half-hour time slots? Is it the same, Jan, across Europe, or is it different to different countries?
Well, they're different markets, and they all have different rules of operating. The UK market is probably closer to some of the markets we see in Scandinavia, but there really are very different market rules in different jurisdictions. But as we move towards more renewables on the system, it will be increasingly important to have the right price signals to encourage flexibility and to ensure that we consume electricity when it makes more sense for the system. I think that's where markets need to be reformed. Often they have been built and designed around having large centralized fossil generation. And now we move towards a world where we've much more decentralized, much more intermittent generation, which will require more flexibility. The kinds of things that we've discussed the last few minutes around flexibility of heating systems will become increasingly important. And I believe it's important to reward customers for providing that flexibility. And that can be through an agile tariff. Another model that is discussed sometimes is to use an aggregator. So you could actually have somebody providing you heat as a service, and they deal with the tariff and all the risk, and the customer simply sees a lower rate. They're paying less for their heat, and they give away the control of the heating system for that to occur. So you can see two different models. And not everybody wants to be exposed to the agile tariff. I guess all of us on this podcast are happy to do that, but there will be customers who feel uncomfortable of being exposed to such varying tariffs. But for them, you could envisage a different model where you have an intermediary taking care of the risk and just providing you with a lower cost of heating in return for giving away the control of the heating system. So that could be another option of still having a flexible tariff, but you not seeing that as a customer.
Now, Peter, you put your system in. How long's your system been in? So you've put a Mitsubishi Eco down in. Is that right?
Yeah, I put it in the autumn.
So it's hasn't been in long, and you're definitely seeing some good gains, yeah.
Yes, it's early days for the technology. I found it quite hard work to understand enough to be confident to put it in. There are relatively few people in the area who understood what was possible. The resources to help me choose what to get were limited. I'm so impressed with the quality of the heat, though. When you run a heating system with water at 35 centigrade in your radiators, first reaction when you put your hand on is, gosh, that's colder than my skin temperature rather than my body temperature, and therefore the radiators are off. But the house is warm and it doesn't overheat, which is very remarkable. So it's a very comfortable form of heat. We run our heating system largely at the same temperature day and night, but then most of the heat gets put in at the night. Obviously, we're just at the tail end of the heating season at the moment, so we did the real learning in December and January.
I'm trying to remember, Jan, you've got a heat pump as well. When did yours go in?
Yeah, ours was installed last year in May, and that's an air source heat pump. And we now have almost a full heating season, and I'm sort of trying to do some review of the data. I have done some initial calculations to look at the cost implications, but I also want to run the numbers on carbon and see, you know, what are the CO2 emissions associated with that. And I expect quite significant reductions simply because of the reduction in energy consumption. And also the grid gets so much cleaner. I mean, the latest figures that I have seen suggest that electricity is now you know, cleaner than gas. And that was nowhere near that, you know, 15 years ago, when electricity was still a lot dirtier and a lot of coal and gas on the system. And now we see, you know, the carbon intensity really dropping. So I think after the first year, we'll see both a reduction in cost and also a significant reduction in carbon emissions, both, of course, which I value very highly.
Yeah, and the other thing I want to pick up on is Octopus, which is your Agile Tariff provider, isn't it? It uses renewable energy, I take it, yeah? That's where its energy is coming from, or predominantly where it's coming from?
Yeah, I think they have a range of different tariffs you can look at as a customer, and some you will have different implications for the investment in renewables undertaken. But largely, yes, Octopus is a sort of green energy, renewable energy provider. But of course, you know, the electricity that you're getting as a customer during peak hours, you know, part of that electricity will always come from fossil fuels because you're just getting the mix that everybody else gets. But of course, with your tariff, you're supporting you know, a provider that is largely you know, investing in renewable electricity.
Now, I've just had a little notice come up on my screen saying we've got about 5 minutes left. Jan, did you have a little screen share, or did you do that? You've done that with us?
Yes, actually, I do. If you wish to see that. So this is just a snapshot from one day in February, and the apologies for that. The red bars here is consumption, and the blue line is the Octopus tariff, and you can see very clearly. So it's jumping around here. Very clearly that between 4 and 7 in the evening, consumption is really low. So about 95% or more of my consumption is outside of those hours, and that's on a cold day in February. You know, and then if you run the numbers, you very quickly get to really low rates per unit of heat generated. And you know, could do the same for day to day with slightly lower red bars, of course, but still hot water is completely produced outside of those hours. I'm actually using you know, Homely to do that right now. So Homely is scheduling the hot water production to find those really you know, low price pockets in the tariff. But yeah, clearly working, and temperatures, as Peter said, really comfortable. Even during 4 and 7, you know, there's not really any discernible drop in comfort. Maybe half a degree on a really cold day, but not more than that.
Now, Karlos, is your system at beta stage, or are you actually now on the market with it?
So we are still selling at the early adopter price. We would like to get some more customers just on our system to get some more feedback, and we're happy to do that at this point because we want this to scale. We want to get as many customers out there as possible talking about the tariffs like this. We appreciate that it's a new thing and it's a little bit scary at the beginning. So I think that word of mouth is really what we're going for. But I think the customers on this program at the moment, if they are comfortable with the system and the way that it's operating, that's confidence for us that it's already market ready and able to do whatever we say on the tin. I also wanted to just on the previous points in terms of carbon and price. So I would expect that in the future, the price is one thing that we're optimizing the system depending on price, but a lot of the time during the cheaper price periods, the power would be produced by renewable sources. So for example, during the very cheap periods when we had a couple of weeks ago, I think we had negative prices where we were actually being paid to consume power. Peter was being paid to heat his hot water. Those times were periods where there was a lot of wind available and that wind just needed to go somewhere. So optimizing on price also should optimize in a way on carbon, and you would be using electricity during the less carbon intensive periods.
Are there certain heat pump manufacturers that are able to hook up to your system, or is it a broad spectrum? Your system can hook up with any heat pump manufacturer.
So at the moment we have a Mitsubishi, we have Nibe. With Nibe system, so Jan is using Nibe Uplink, where he didn't even actually need our hardware. He just connected it through the API. We have a Danfoss, we have Kenza, we have Samsung.
Do you have Mastertherm? Because I was speaking to Nick Salini yesterday, and I think he's been interacting with you guys, hasn't he?
Yes, so we have Mastertherm as well, and with Mastertherm we can do a lot more interesting stuff in terms of controls. So yeah, we're trying to connect as many heat pumps as possible. There are a few that we just haven't had the customers yet coming to us. We're looking at integrating with LG, with Daikin. I think those are the major ones that we've had a chance to actually play with.
Right. Well, maybe I'll nudge the others for you and get them to come on board. Well, it's been a very interesting chat. So I'm sure we will revisit this topic again, and I'm sure some listeners will be quite interested to learn a little bit more about Homely. Where can they go, Karlos, to find out a little bit more about you? You've got a website.
Yeah, so our website is homelyenergy.com. We have a little bit of information on how the system works, what it's actually doing. We have a short video to just explain the concept. We also have a little bit on how to get a heat pump. So we realized that when people were coming to our website, they sometimes didn't even know what a heat pump is. They just wanted to understand a little bit more how to actually reduce their heating costs. We have a little section about different government incentives, for example, for installing heat pumps, and who certain people to go to get heat pumps installed.
Well, it sounds all very interesting. I wish you all the luck. So I can just see my session's now coming to end. So I'd like to thank all my guests, which is Jan, Peter, and Karlos. And once again, I'm sure you'll all see us all again chatting about this. Thank you very much to you guys, and thank you to my listeners. Thank you.
Thank you.
Thank you.